All right, you're recording now?
Okay. So for this problem, it say that there's an amount of aniline that was combusted in a bomb calorimeter
Mm-hmm.
with heat capacity, and then the temperature of the bomb calorimeter rise from 29.5 to 69.8, and then they want to find the delta H of the combustion reaction for aniline.
Mm-hmm.
So first, let's write the combustion reaction. So we have aniline C6, H5, and H2, and then
Mm-hmm.
combustion. So it's react with
Oh,
oxygen
two. Mm-hmm.
to form CO to form carbon dioxide, water, and a byproduct of nitrogen, N2. I'm gonna um, balance the equation. So I have six oxygen. I mean six carbon. So I have six here. Um,
Wait, how do you know
seven.
N2's gonna be there?
Usually the problem will tell you the products of like what kind of nitrogen product that would form. For
Mm-hmm.
this problem, it actually not
It doesn't tell you.
doesn't matter that what product it is.
Oh, okay.
It could be N2, N2O, NO2, NO. The problem, like if it is significant, the problem would probably tell you what it is.
Okay.
We have seven nitrogens. I mean seven hydrogen. So we have
Mm-hmm.
7/2 here. So I'm gonna multiply everything by two. So I have here is two. So I have here is 12. Um,
Seven.
and then this one is seven.
Mm-hmm.
Two nitrogen. So one here. So 12 plus 12 times 2 is 24, plus 7 is 31. So this one I have 31/2.
Okay.
Right. And then this one we have delta H of combustion. Right.
Mm-hmm.
And then the system here has Q system because this is a calorimeter problem. So the Q
Mm-hmm.
system is 0 because there's no heat exchange to the environment. And then the system contain the combustion reaction. So I have Q of combustion. And then the calorimeter itself. So I have Q of calorimeter. So plus Q of calorimeter will be totally 0. Right?
Mm-hmm. Mm-hmm.
So you can see that so if we move, I'm going to subtract Q calorimeter on both sides. So that one would give me Q of combustion reaction is equal to negative Q of calorimeter.
Mm-hmm.
And then we know that Q of calorimeter can be calculated using the formula C delta T,
Which
because
is
Q
also
of calorimeter is equal to C times delta T, with C is a heat
heat
capacity,
capacity. Mm-hmm.
and then delta T is a change in temperature.
Mm-hmm.
And then always finals minus initial.
Mm-hmm.
So that one we would have negative heat capacity is 4.25 kilojoule over Celsius multiplied by final, which is 69.8 Celsius. Subtract 29.5 Celsius, and that one would give us 4.25 times 69.8 minus 29.5. This one will give us 171.28 kilojoule. And then they want to find the delta H, and we know that delta H is equal to Q over N, which is the heat over the moles. Uh,
Which
so
is
which? we would have to find the moles first.
Okay.
So
Wait. Hold up. What happened
yeah,
to the Q comb? What
Hmm?
happened to the Q of the combustion?
Q of combustion. Q of combustion is, oh, we have a negative here. Q of combustion is equal to negative of Q of calorimeters, and then we just did
Oh.
the math, so we just calculated Q of combustion.
Oh, so that way you can find the
Yeah. So
oh.
delta H of combustion will be Q of combustion divided by the moles of aniline.
Oh. So in the moles of aniline is
Yeah.
whatever
So we can
4.98
calculate
is.
moles of aniline
Oh shit.
by converting from the mass, and then we started out with 4.98 gram of aniline, and then we just converted. So we need moles, so moles on top, and we don't want grams, so gram on the bottom. And then the molar mass is
Mm-hmm.
given to be 1 mole for every 93.13. And then that one is 4.98 divided by 93.13. And that one would give us 0.053.
You're not gonna show me how you get 93.13?
Oh, it's given here.
Oh, okay.
In case it's not given, you can see that it is C6H5. Sorry. And H2. So we just basically use the molar mass of each of the element. So we have 6 carbon, and each carbon is 12.01 gram per mole,
I
plus
see.
5 hydrogen, which is 1.01 gram per mole,
Mm.
plus 1 nitrogen, which is 14.00 gram per mole, plus 2 hydrogen, which is 2.1.01 gram per mole. And then that should give us approximately 93.13 gram per mole.
I see.
So now we just use the formula that we was given up there. So delta H of combustion would be Q of combustion divided by moles of aniline, which is negative 171.28 kilojoule over 0.053 mole. So negative 171.28 divided by that. It's
Negative.
approximately negative 3203 kilojoule per mole. And significant figure is negative 3.2 times 10 to the positive 3 kilojoule per mole. And that would be B. For the significant figures, so we have the decimals over here, so we move it to the left. 1, 2, 3. So because we move it to the left, then we have to have a positive 10 power.
Thank you. I didn't know how to do the sig figs. How do you know it's moving 3?
Well, because we usually keep the first, we usually keep one non-zero digit, and then the decimals when we do significant figures, like negative 3.2 or 5.1 or 1.6. We usually have like non-zero decimals, and then decimals, and then the 10 to the power of something.
I see. I
But
see.
it's not a strict rules when writing significant figures. I mean scientific notation.
I see. Thank you.
Yeah. Okay, so I'm gonna stop the recording here.